Section 9.3. This is a combined section on simulations and applications in probability, like odds and expected value. Now, a simulation is actually kind of a cool thing that you can do to find an experimental probability, especially if the actual experiment, let's say, is too complicated or too difficult to do or too expensive. That was an example that the book gave. A simulation then is just some way that you can do this experiment and in a way that closely resembles the actual situation. Okay. Now, more often than not, when we do these simulations, we try to use something called a random digit table, or we can use the calculator for that. So let me just show you how this is going to go down here. So use your calculator or a random digit table to pick 5 students out of a class of 35 to be group leaders. Now, for a simulation like this, you could easily put 5 names in a hat, or some other random way of doing it. But you can use a random digit table, or you can use your calculator. Your calculator does have a random digit table built in, even though it's not truly random because it's some kind of algorithmically generated. So if we hit the math button, you can see the probability menu up there. Option 5 says random integer. We want an integer between 1 and 35. I'm going to label the kids. There's 35 of them. I'm going to label them 1 through 35 with a number. And then let's just see what comes up. All right, number 8. There's a group leader. Kid number 13. There's your second group leader. Number 1. Number 33. Number 4. There's your 5 group leaders. Now let's say you want to keep going. And you want, say some co-leaders for each group. Okay, well, let's just keep hitting enter. Oh, we got a 1 again. Oh, that was good. I was actually hoping that was going to happen. Now, if you get a 1 again and say this is somebody you want for like a co-leader for your groups, you would just ignore those repeats because you've already picked that child. So, okay, you just ignore that. Okay, so now child 20 is a co-group leader. So if I just keep hitting enter, it's just going to keep randomly generating numbers between 1 and 35. Now you can also use a random digit table for this. Well, that's a lot more awkward, but let me find one real quick here. Okay, so let me see if I can get this under my camera without getting it all wackadoodle out of my place here. So this is in your book. And it just gives you just a table of random digits. So the thing about using a random digit table is that it is just, chunks of digits. So if you're talking about kids 1 through 35, you're going to have to use these digits as a 2-digit combination. So like 36, 42, 29, 32. That's going to be problematic. Okay, sorry, there's not an earthquake happening. It's just me trying to hold this camera because it doesn't sit right on this book. That's going to be problematic, right? Because the kids are only numbered 1 through 35. So there's going to be a lot of numbers you're going to have to skip because they're above 35. So yeah, these kind of things, I don't know. I mean, they're kind of nice to use, but if you've got a calculator that can just randomly generate those numbers that you need in that interval that you need, that's far superior to use. So, all right, let me put this thing away. And we're back. Okay, so we're going to use the calculator, and let's see. So we did that, and we used the math button. We went over to probability, and then I think it was option 5 where it said random integer. So we did random integer from 1 to 35. So that just tells you the interval in which you want those random integers generated. It is automatically going to be an integer, and it's just between 1 and 35. And then hit enter until you get 5 different numbers. So you're going to exclude any repeats for this particular case because we're picking kids to be group leaders. Why did I pick 5? For 5, why did I hit 5? Enter 5 different times, because I'm picking 5. Now, true randomness is actually kind of hard to achieve. There's just certain naturally occurring things. If you try to just pick a random number out of your own head, you're going to find that you have a certain bias that you really didn't think about. So, a random digit table or calculator is really the best way to achieve true randomness, even though even that's kind of algorithmically generated. So, all right, let's design another simulation here. And let's use the calculator to run away. And let's do the random integer generator here to randomly answer a 20-question test. Now, that 20-question test, let's suppose that it's all true-false questions. So what are we going to do? Well, if they're all true-false, we're going to use the random generator on the calculator. What numbers are we going to use? If it's only a true-false question, we're just going to use 1 to 2, where let's say that 1 is true and 2 is false. You can certainly use 1 is false, 2 is true. It doesn't matter. And then all you have to do is keep hitting enter, and whatever number comes up, that's how you answer. You're going to hit enter 20 times. Why 20 times? Because it's a 20-question test. You're going to hit enter 20 times, and you're going to answer based on the random number that's given to you. Now, in this case, you're not going to exclude any repeats. Last time we wanted to just ignore any repeats because we were picking group leaders, and we don't want one kid to lead like 3 different groups. Here, repeats are okay because I'm answering a true-false test, so of course I'm going to have some repeats. So it just depends on the situation as to whether or not repeats are okay. Now for part B, let's modify this slightly, and let's suppose it's a multiple choice test and there's 4 choices for each question. Okay, so now I'm going to use that random generator. Now I'm going to use 1 to 4, where let's say that 1 is answer A, 2 is answer B, 3 is answer C, and 4 is answer D. Again, I'm going to hit enter 20 times. Repeats are okay. And I'm going to answer the question based on the random number that's given to me. And again, repeats are okay. So just to show you, I'd go to random integer 1, 4. All right, 2. That means first question, the answer I'm going to put is B. Then I'm going to put A. Then I'm going to put D. D. A. C. D. C. Okay, so I just keep that going. So I don't actually want to see the numbers here. I'm just more interested that you know how to design the simulation, how to assign values to the numbers that you're generating, how to make sense of those, how many times to run the simulation, what to do with the answers. So all that kind of setup is what I'm more interested in here for this. Well, let's do another simulation. Let's suppose there's 8 colors of gumballs in a machine. Let's use the calculator. I'm not going to use a random digit table. To find about how many quarters I'm going to need to use before I get a tasty pink gumball. Now this one's going to be a little bit trickier. Okay, so about how many quarters do I need? Let's assume that these are all equally likely. So let's use a random number generator on the calculator, and let's use 1 to 8. Now it doesn't matter what the 8 colors are exactly, it just matters which one I'm going to call pink. That's the only one I'm interested in. I don't need to give the other ones a name. But if you want to be, kind of fun in a setting, with kids, you can certainly give all those different colors a name. And let's just say that pink gumball is number what? I don't know, 2? Let's say 2. You could say 4. You could say 1, 2, 3, 4, 5, 6, 7, or 8. It doesn't matter. Where'd I get 2? Pulled it out of my butt. That's all. So, let's see here. Math probability 1 to 8. All right, so I'm going to hit enter. Now, how many times do I have to hit enter? Well, I'm just going to hit enter until I get the number that I need. In this case, it was 2. Okay, so about how many quarters? Well, so my first simulation, it took me 1, 2, 3 tries. That would be the equivalent of 3 quarters, right? First quarter got me the color for 1. Second quarter got me the color for 8. Third one got me the tasty pink gumball. So that would be the equivalent of the quarters. Let's run the simulation again. So let's do, now really I don't have to start it over. I can just keep going. Oh my goodness, first quarter. So second simulation, 1 try. Okay, so let's start this over. Okay, so now I got 7, 3, 5. Okay, so I'm at 3 quarters. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I'm kicking the machine by now. 23 quarters. Holy schmolies. Now, obviously, because this is all random, your data is not going to be the same as mine. So as you're running these, if you get different numbers, it's okay. I'm kind of glad that that one ended up being some stupid big number, so that in case, because that happens sometimes, because I didn't want you getting some ridiculous big number being like, well, wait, I did something wrong. No, it just happens. All right, so let's do it again. Now, how many simulations do we need to run exactly? Well, part B. Use your calculator or table to find the experimental probability of getting a pink gumball. The experimental probability. Now, the theoretical probability is 1/8. The experimental probability, well, this is going to be how many 2s I get out of how many tries, because it's a probability. That's why I'm running a whole bunch of simulations. I'm running a simulation until I get a 2. Here, I only had to run it 1 time. Boom, 2 showed up. 23 times before a 2 showed up. So let's run it a 4th time here. All right, so I'm looking for another 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that time it took me 11 tries to get a 2. Are you guys familiar with using these little quotes as a shortcut to not have to write the same thing above it? I hope so. If I do anything like this, if I abbreviate like this and you guys don't know what I'm doing, just feel free to ask me, because sometimes I think stuff's common, but I'm old, so who knows. Okay, so I ran the simulation, a few times. Let's see here. How many, let's do the probability. So that was part A. And I did all of this knowing that probability question was coming up. So the probability would be the number of 2's, remember, because those are pinks, out of the total number of times the simulation ran. So the number of 2's that appeared out of the total number of, I shouldn't say simulations ran, that makes it sound like I just ran 4 times. The total number of quarters used. So we'll say the total number of tries, since that's what I called it up here. All right, so I did the simulation 4 times. So I got 4 2's. Because I stopped each time I got a 2. How many times did I run the simulation? Well, I ran it 3 times to get a 2 here, once, 23, and 11. So I just need to add those together. So that's what, 23, 26, 27, 28, 38. So 4 out of 38. That's my experimental probability. How close is that to 1/8? Let's see. 4 out of 38. That's about 0.105. 1/8 is what, like 0.125? Okay, that's not too bad. We expect that the more we run the simulation, the closer this experimental probability will be to the theoretical. So this was my experimental probability, and I just converted it to a decimal to make it easier to compare, because I can't look at those two and be like, oh yeah, they're totally close together. So yeah, a little easier to compare to that theoretical probability. Now, you don't have to use numbers to do this, okay? So if you're in a classroom with kids, this is kind of boring to do numbers. You certainly could do it where you have a box or a cup or something that has, different color marbles that simulate, getting that gumball out of there. So you can certainly do that differently. So that's the end of simulations. So now we get to do odds and expected value. So this is probably a good stopping point for us to come back and do the other half of the section in terms of the odds and expected value and everything. So we're going to go ahead and just stop this part right here.